Hello everybody, how y'all doing? I hope everybody's having a great day. It has just came to my attention that you guys need to understand dynamic and static binding for the midterm. It's a very simple concept, it's nothing too spicy, and some of you might have already ran into it. And it's something you've already been accomplishing, it's just terminology and knowing what's happening in the compiler end. And so I'll give you a quick couple examples for you to understand it, and I hope you understand it. So I'll just start with bringing a library, because I'm going to be printing some stuff. I'm going to make a function that will add numbers. Okay, so it's going to take A and it's going to take B. And what this will do is it will just print me the addition of both. Right, so A plus B. And then what I'm going to do is I'm going to copy this function and I'm going to print another one. I'm going to paste another one. I'm going to give it int C. And you see what's happening here. Let me do an int main. When I call add numbers and I give it 1 and 2, the compiler knows to call the first function. And the reason being, the reason being is because it knows this has 2 inputs. I'm giving 2 inputs. I'll call this one. This is statically set. The compiler knows it's like hard coded, right? When I do like add numbers, and I do int A, int B, and well, it would be actually numbers. So 1, 2, and 3. This is also statically set because the compiler knows these are 3 inputs, 3 variables. That's static binding. The compiler will bind this one to this function, and will bind this one to this function, statically bound, and it's it's set. The trickiness, it comes when we do inheritance. So I'm gonna create 2 classes. One is a parent, and it's gonna have a public void function that will print me parent. So I'm gonna name it name, and I'm gonna have it just print out parent. There we go. Nothing too complicated. And that's that. What is going on here? Oh, I forgot ace. There you go. I'm gonna copy this class and I'm gonna give it another one. I'm gonna name this one child. There you go. I don't have these functions anymore. So I'm gonna create a child instance. And I'm gonna create a parent instance. Right? Now when I do child.name, right, and when I do parent.name, these are statically set because the compiler knows that I'm gonna have a child instance, and which is child type, and I am calling this function, and we'll bind it to this one. And also when I'm calling this, we'll bind it to this function. This is statically made. But the problem is when I inherit parent, all right, so when I inherit parent here, right now, this is fine so far. Okay, so still, this is bound statically, and the compiler knows what it's pointing to. But when I make this, so yeah, I'll do another example under. Actually, let's run this so you guys can see the input. There you go. You see it has child and parent. And now when I do parent pointer, I'll make it a pointer, and I make this point to the address of my child. Okay, and I compile and I run. Oh, I didn't print it. So when I do pointer to name and I run it, watch, it also prints me parent, even though I have it pointing to child, and it's supposed to bind this to this function, but it doesn't. It binds it to this. Why is that? It's because this is not a virtual function. The compiler knows that when the compiler thinks, okay, just so you guys know, when the compiler thinks and it sees a parent pointer, what it thinks is I am going to point to a parent. It doesn't think I'm going to point to a derived class. It can point to a derived class, but a derived class at heart is a parent, right? So this class is the parent. This class is derived from the parent. So at heart, when I'm pointing to the child, the compiler thinks I'm pointing to a parent because it's inheriting. And so this is still static. All right, this is still static. This will not change. Doesn't matter what I pass this right now, since this is not virtual, it will always, doesn't matter what child I pass it, it will always point to parent because I told it it's a parent pointer. The problem is when this becomes virtual. So see, when I make this virtual, if I can spell it right, when I make this virtual, what the pointer thinks is like, okay, I am a parent pointer, and I'm gonna point to a parent, which it is. It's still pointing to a parent. So even though it has the address of a child, it's still first pointing to a parent. But then when I run it, it goes into the parent, it sees, oh, this is a virtual function, then it goes to the child, and it points to this function, and it binds it. Then it binds this to that instead. This process happens at runtime, not compile time. You see right now when I run this, it prints me child. Because the way it works is, you see here, this is hard coded. It will always be pointing to parent. It will always get you the parent function. It will always get you the child function. And even here, earlier, when this wasn't a virtual, when this was like that, whenever you call the name function, it will give you this. That's what makes virtual functions virtual, by the way. What makes virtual functions virtual is that it tells the compiler, this is not the function I'm using. I want to use the most derived version of the function. And the compiler sets that at runtime. So when the code compiles and it runs, there's something called the vtable that the compiler creates at runtime, and it shows each function and its most derived function. So we'll have this function and its most derived function, which is this, and this happens at runtime. And so then, when you call this pointer on this name at runtime, the compiler then goes like, okay, I need the name. It goes to parent, it goes through the vtable, and goes like, what's the most derived version of my name function? It finds it, then it calls it, and that happens at runtime, and that is called dynamic binding, because you bind it dynamically at runtime. You don't statistically or statically bind it file time because it's not hard coded. The compiler thinks, okay, I'm a parent pointer, but it doesn't know whether it's going to point to a child or whether it's going to point to a parent. You're going to think, why doesn't it know though? I'm passing it a child. Because the compiler is lazy as fuck. And it goes like, you know what? I'm a parent. I'm going to always assume I'm going to point to a parent. And even here, it is pointing to a parent. It first points here. Then it goes to the derived class. So, when you think about it, whenever you have it virtual, that makes the compiler says, you know what? I'm not dealing with this bullshit no more. I'm going to leave this for later. And then at runtime, when you try to call the function using the pointer, it will go to the main function, search up the vtable it created, find the most derived version of the virtual function you made, and then it calls it. And this whole process happens at runtime. And that's how you know this is done dynamically, because of this virtual function. Capiche? Makes sense? I hope you guys understood it. This is a short concept, but I tried to be lengthy and keep repeating myself so you guys really process what's going on. And that's for dynamic and static binding. Thank yous.